10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
The PSLV C-57 is prepared to launch the 1,480 kg AdithyaL1 spacecraft into Earth-bound orbit, from which it will be placed into a halo orbit around the L1 point in 4 months. The satellite is intended to study the Sun and how it impacts the heliosphere. The Sun, which is the center of our solar system and has always fascinated humans, is a ball of hot gases formed by the nuclear fusion process. The visible outer surface of the Sun is known as the photosphere, followed by the chromosphere and then the corona. After initially dropping through the chromosphere, the Sun's temperature abruptly rises in the corona, reaching extremely high values of 1 to 3 million Kelvin. The AdithyaL1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. The Visible Emission Line Coronagraph, VELC, investigates the solar corona and the dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SOOT payload, scans the solar disk in near ultraviolet light and detects fluctuations in solar irradiance. The Adithya Solar Wind Particle Experiment, ASPECS, and Plasma Analyzer Package for Adithya PAPA payloads investigate the solar wind and energetic ions, as well as their energy distributions. The Solar Low Energy X-ray Spectrometer, SOLEXIS, and the High Energy L1 Orbiting X-ray Spectrometer, HELIOS, analyze X-ray flares from the Sun over a wide energy range. The magnetometer payload is designed to measure the interplanetary magnetic field at the L1 point. AdithyaL1 is equipped to take in situ measurements of charged particles and fields at L1 and is dedicated to studying the Sun across several energy bands. The Lagrange point L1 is located around 1.5 million kilometers from the Earth, between the Sun and the Earth.
18 minutes and counting.
These observations are best made from a vantage point that provides a continuous view of the Sun. All payloads are designed in close coordination with ISRO centers and national laboratories like as IIA, IUCAA and PRL. With this mission, ISRO will once again demonstrate its position in space exploration.
Stage separation and continue to thrust for 11 seconds. The second stage, PS2, commences its operation 200 milliseconds after the separation of first stage. By this time, the rocket would have attained 55 kilometers altitude. The closed-loop guidance is initiated, which compares the present stage of rocket to the intended injection point to compute an optimal trajectory. This happens while the rocket is at 59.7 kilometers altitude. At 204 seconds into the flight, the payload fairing is separated as the launch vehicle attains 113 kilometers altitude and the dense atmosphere is no longer present around. These events are taking place in the operational regime of the second stage, which lasts for 153 seconds. PS2 was separated 262.4 seconds into the flight at an altitude of 130 kilometers, while the relative velocity is 4.9 kilometers per second. The third stage, PS3, ignites about a second later and burns for 118 seconds, during which time it adds 12 kilometers to the altitude and enhances relative velocity tremendously from 4.9 kilometers per second to 7.3 kilometers per second. There is a coast phase of 200 seconds that follow PS3 burnout, during which there is no thrust being developed, but the rocket continues to be steered. At 581 seconds into the flight, the PS3 separates, and the last in the
T-minus 8
fourth
minutes
stage
and
of
counting.
the rocket, together with the AdithyaL1 spacecraft, coasts for a long time thereafter.